Hello and welcome to this video tutorial on interfacing of LCD to the microcontroller 8051. So basically LCD is a output device, and whenever you want to see what process is going on inside the microcontroller or the result, so there should be some display device connected. So we go for the LCD in most of the embedded systems because of its price. So it is a low cost device, its power consumption is less, and its ability is to display, you can display the numbers, characters and graphics also, and then it is very easy to program for the characters. So that is what we have to go through for the today's session, where we will be trying to understand how I can interface LCD to the microcontroller 8051. Now that interfacing will be a microcontroller 8051 connected to the ATC. So that interfacing we will use, so I will just zoom it so to understand what that interfacing is. So this is what is the interfacing. So port 1 of the microcontroller is connected to the data lines of the LCD. Then there is one control signal. Control signal is RS, so it is a register select. So whether you are dealing with the data, whether you are trying data, you are giving data or command, so that will be decided by this RS register. And then R oblique W bar, so whether you are reading or writing to the LCD, and this is what enable bit. Okay, so one pulse, enable pulse, you have to apply on this particular pin. Not only that, there is some provision that you can have a backlight for this particular ADC, and that backlight intensity can be adjusted by varying this particular pot value, and otherwise that VCC and VSS are the supply voltages which are required for working of this particular LCD display. So now whenever you are connecting this LCD display, so you remember inside the LCD display itself there is a microcontroller. So and to that microcontroller you can give certain commands. So there is a set of instructions, or what we can say commands, which can be given to the LCD. So prior to that, this diagram talks about the what are the pins available for the LCD interface, and then what are the different LCD commands. So these commands we will be using in our project. So let us create a project for LCD interfacing. So open the keel, and in the keel what you have to do is you have to create a new project. So let us go for creating new project. So let us create that project in some folder. So we have one folder, one already interfacing of LCD is the folder. So let me give the name to the project as LCD. Okay, so this is the project we have created. Then it will ask you for the microcontroller for which you want to do this project. So we will select the Intel manufacturer, and the chip we select will be 8051AH. So we will not go for any startup code. So now what you have to do is you have to add the file for which ASM file. So either in the editor you can type this file, or already I have that type file. So what I do is I add that particular file to the project. So that is the ASM file, so lcd.asm. so this file I add to the project. So now let us view what that file is. This is a project, so this is a LCD interfacing program. So first let us try to understand this particular program. Prior to that, let us check whether there is some error in the program or not. So I build the target. If the message is zero error, zero warning, so there is no problem, so good. So we are getting again some error, so there is a syntax error. Fine, so the problem is with the characters which you are giving, so single quotes are expected there. Okay, fine. So by making those changes, again let us try to build the target. Fine, so we are getting no error and no warning for this particular project. So now let us try to understand what this particular code is. So this code is for the LCD interfacing with the interfacing which is shown earlier or you can understand that interfacing with the help of this Proteus simulation also. So how LCD pins are connected to the microcontroller. So this is what is the connectivity. So the port 1 is connected as the data lines, and then VDD, VSS and VEE are the supply lines. One is for VDD, VSS are for supply, and VEE is for the intensity control. RS is for the register select, you are selecting the data register or command register. RW is for read write, and then E is for the enable, and then that backlit intensity can be controlled through this particular port. So now as it is a simulation, we have not added any microcontroller. Clock crystal connect is not there, as well as reset circuit and all those things are not showing. Whenever you are doing a practically implementation of this, always you should connect a crystal here, then that capacitors are required for that crystal, then reset circuit, power on reset you can circuit you can have, or there you can provide some reset button. That EA bar has to be connected to VCC if you are not using external memory. So this is what is the hardware interfacing. So to implement this hardware interfacing, this is the code written. So let us try to understand, let us go for understanding this code. So it starts with, initially you are making initialization of the LCD by sending different commands. So what I'm doing is I'm using a subroutine called as command write, and then to that I'm sending a value, what you can say that we call it as a command. So already there is a set of different LCD commands and which are sent to the LCD, and as I said, in LCD there is a microcontroller that will execute that command, will understand what user wants to do with that particular LCD, and then it will again take some time for execution of that command. So you need to provide some delay for executing a particular instruction. So this 38 stands for 2-line and 5/7 matrix display. So this command, I'm loading this value, I'm loading into the accumulator. I give this value, accumulator contains, I'm calling a function called as command write. We will see command write and data write functions later. And then I call delay, then I give 0E command. 0E stands for LCD on, cursor on. Then I give command 01, I want to clear the LCD display, so whatever previous display was, that gets cleared. Then I give 06, so it will shift the cursor to the right position. 84, so then where you are going to start the display, so that will be cursor at line number 1 and position number 4. So every command, after every command I'm calling a functional command write, and then I'm calling delay. So this is what we can say initialization of the LCD for displaying some data. And after initializing LCD, what you are doing is you are sending the data. So see, whenever you are sending the data, again whatever character you want to display, that I am loading in the accumulator, and I am calling a function called as, rather subroutine called as data write, and again I am calling the delay. So whatever character you want to display, so I want to display HELLO, so hello is the message I want to display. So after every character I call data write, and then I call delay subroutine. So this is what is your program. So whatever text you want to display, so for that character you have to load in that ASCII value of that particular character, you have to load in the accumulator. So when you write that character in the double quotes, the skill software assembler indirectly will convert its L into its ASCII value. Okay, so now let us go for understanding for the functions which are used for this. So here I'm using the function, one is command write and another is data write. So first let us try to understand the function command write. So what I'm doing in the command write function is, first in the accumulator you have already the command available, so that I load into P1. You know that P1 is connected to the data lines of the LCD. So then what I do is I clear P2.0. P2.0 is RS, and RS is equal to 0 means you want to deal with the command register, and then you want to write it as a command. So it is read oblique write bar pin. So if I make it 0, then I am going to write. So I make enable pin high, I call delay and make that particular pin low. So this is what is the command write function. So basically if it is a command, RS is equal to 0. And then if I compare, there is one more function called as data write, and if I compare command write and data write function, they are 99 almost same. Only difference is here I have clear P2.0 and here I have set P2.0, because if I clear I will be using that as a command, and if I'm setting that particular P2.0, then whatever I'm sending the data, that will be treated as a data and not command. all other things are same in this particular subroutine also. So finally you require some delay. Whenever you give in the command, that command is executed by the internal microcontroller of the LCD, and it will take some time for its execution. So what we do is we give some delay. So for a delay generation, a simple program is you load some value in the register and you go on decrementing, and this will take some time. So again, this is the delay subroutine return. So this program consists of initializing LCD by sending different commands, then sending the data. And for sending the commands and data, we have used two functions. One is called as command write function, and another is data write function. And for all this program, we are using this particular delay subroutine. So now what next you can do is you can build the target, and then you can enable the option to create the hex file. So in the output, so I enable this option to create the hex file. And now what you have to do is again rebuild the target. It will create the hex file. Now you open this particular Proteus simulation, and then you have to give the path for that particular hex file which is created. So this lcd.hex is the file, hex file I load into the microcontroller. And then what you can do is you can run this simulation and see what message I'm getting is hello TEXTC. So what is happening here now in this display, one problem I'm facing is actual message I have written is for display of the characters. One is hello, the message is hello, and then it is TE space EX TC, but I am not able to view that C part, and then exclamatory mark is also there. So what can be done is, what is the problem is the initialization of LCD for the display. So initially line number 1 and position number 4 is decided by this particular 84 value as the command. So what I do is, instead of 84, let me make it 82, and then again if I rebuild this particular target, hex file will get created. And then what I do is again I run the simulation. So when I run the simulation, see what message I get is what data I transmitted to this particular LCD. So this is how a LCD can be interfaced to the microcontroller, so that you can view some output by the microcontroller. So you can output some data, rather more specifically you are going to output the ASCII values, and those are going to be getting displayed onto this particular 16:2 LCD display. So this is a simple simulation where I can display some message onto the Proteus by using a software. So there is you may feel that the code length is more, but most of the code is repeated. So whatever code I have to display E, okay, so only character is changed, all those functions calling is same. And not only that, if I see the functions like command write and data write, so those two functions are also exactly same, except there is only one change in the command write function. What I do is I clear this p2.0, and in the data write function what I do is I set p2.0. so otherwise that coding part is also same. So this is how you can do the interfacing of the LCD display to the microcontroller. So according to the message which you want to display, then you can change these characters, and those characters will get displayed onto the LCD display. Thank you.